How about this question here? Joe and his brother Bo, have a combined mass of 200 kilograms and are zooming along in a 100 kilogram amusement park bumper car at 10 meters per second. They bump into Melinda's car, which is sitting still. Melinda has a mass of 25 kilograms. After the collision, the twins continue ahead with a speed of 4.12 meters per second. How fast is Melinda's car bumped across the floor? So we need to find the velocity of Melinda's car. Let us do that now. Alright, so here we have everything set out for us. And if you watched the last video, you would know that the law of conservation of momentum states that the total momentum before, so that's right here, the total momentum before the event is equal to the total momentum after. Sum of momentum before is equal to the sum of the momentum after the event. It could be a collision or a separation. The formula for momentum, mass times velocity. So we can use u to represent our initial velocity and v, our final velocity. So here we have a diagram of Joe and Bo. They have a combined mass of 200 kilograms, plus we'll have to add the mass of what they're traveling in, which will bring us to what? 300 kilograms. Their velocity is 10 meters per second. And then we have the momentum of Melinda, which would be 0 because she has no velocity. She's still, but she has a mass of 25. She has a mass of 25 kilograms, but that was added to the mass of the car that she's in. But the total momentum she has before the collision would be 0. Over here, we have after the collision where Bo and Joe hit into Melinda. Melinda was still, but after Bo and Joe hit into Melinda, Melinda flew off with some velocity we're going to calculate, while Joe and Bo continued in the same direction. However, their velocity decreased. Have the same mass, but their velocity decreased. Melinda and the car has a combined mass of 125 kilograms, and this is the unknown velocity of Melinda and the car that we need to find. So we go ahead and we compute our left hand side. This is the total momentum before the collision, and we have the momentum of the boys after the collision. We need to find the velocity of Melinda after that collision. So we go ahead and we subtract 1236 from both sides of the equation. We're left with 1764 is equal to 125 of some velocity. When we divide both sides by 125, we're going to get v by itself, and 125 into 1764 gives us 14.11, so to 2 decimal places, meters per second. So, and it holds true. Melinda is less massive, so if they hit into Melinda, she's going to increase in velocity and possibly a greater velocity than what the boys had because of how less massive she is. So that's it for the run through.